Understanding consciousness is at the core of our existence.
Any feeling of love, of hate.
What makes us enjoy, what makes us taste, what makes us have feelings, what makes us, be sad.
It could be as banal as tasting a, slice of old stale pizza.
If you think of consciousness as what gives us existence, then we need to understand that to understand who we are, period. Understanding how consciousness, which is or in some ways is non-material, how does this property get into the material world is the biggest mystery.
Consciousness is not in the foundational equation of physics. It's not in quantum mechanics. It's not in general relativity. It doesn't seem to be in the endless ATGC chat of our genes. Yet once again, we are conscious. What we need is a fundamental, empirically accessible and testable theory that tells us which physical systems, under what conditions, have conscious experiences and which ones will never have a conscious experience. Studying consciousness is a little bit more difficult than studying black holes or viruses or nerve cells. Consciousness is different because consciousness has what's known as a first-person property. Only I have direct acquaintance with my conscious experience right now.
And some people say it's such a mystery, it's out of our reach. Biology does seem to support consciousness. I think it's reasonable to assume that. Is it the only thing that can support consciousness? Maybe not.
Does the sun ever feel like something? Does a tree ever feel like something? Does a dog ever feel like something? So for certain of these systems, we have precise answers, but right now it's mainly based on intuition. I believe you're conscious because you're similar to me, but the further away we go from things that look like me, the more difficult this inference process, right? So in a squid, it doesn't even have a spine. Is a squid conscious? I believe so, but it's more difficult to say. It's a plant conscious, that's much more difficult. So that's why we fundamentally need a theory, and that's not an easy task.
There's many reasons why understanding consciousness is important. One of those is for the medical decisions that we make, but the second one is for the ethical decisions that we also make. Take a car, self-driving car, is conscious and then kills a person. Are we going to feel differently than if this self-driving car is not conscious? You're going to trial the engineer who actually, created the algorithm to, create that. So it has consequences. When are babies conscious? When someone loses consciousness, right? So we make a lot of medical decisions these days based on whether or not we attribute life and consciousness to certain, individuals or animals.
It's only within the Enlightenment that we are beginning to understand that the brain is really the seat of the mind and in particular of consciousness. Until then, people thought predominantly it was cardiac-based thinking, and you still see that reflected today. I love you with all my heart.
Many years ago, we thought it was in the pineal gland. Theories have been evolving, right? The current understanding is that the brain is the most likely candidate. And which parts? Is it the whole brain? Is it a little bit of the brain? Is it the connections of the neurons? Are the neurons themselves? Is it the way in which they are arranged? And these are the questions that we're trying to address.
In fact, there's a little brain at the back of your brain called the cerebellum. It contains roughly 80% of all the neurons in your brain. And if you lose this, because let's say you had neurosurgery, you might not be able to type very fast on your iPhone, or you might not be able to play a piano anymore. But none of these patients complain about loss of consciousness.
So now we know that the hippocampus is most likely not necessarily really relevant for consciousness, because you can take it out. Of course, you lose memories, but you don't lose your experience.
We now know that consciousness really is generated by the outermost layer of cortex, the neocortex. It's 2 to 3 millimeters thick, just like a pizza. We also know that if I lose access to my entire cerebral cortex, for example, because I have a massive car accident, I become completely unconscious. So then the next question is, well, where precisely in the neocortex? Is it all of neocortex? It doesn't look like it. To understand memory and consciousness and behavior and perception, you need to understand relevant actors. In this case, the atoms or the molecules of the mind are neurons and collection of neurons. And so I need to be able to understand how many are they, where they located, can I record from them?
We do need technologies by which we can measure how does one neuron talk to another neuron in another area. Maybe actually everything happens in the connectivity, in the connections between these two.
Once we have the tools where we can delicately and reversibly turn on or off specific subset of neurons, so I can just right now turn off your ability to see in color, very precise with millisecond precision, and then I can understand much better the causal relationship between particular bits and pieces of the brain and conscious experience. That still doesn't, of course, answer the fundamental challenge. So partly understanding consciousness is a conceptual, very challenging problem.
The Templeton Foundation has the interest of trying to eliminate theories. And by elimination, what they mean is that you find evidence that is substantially compatible with certain theories and incompatible with others. And by doing that, you diminish the weight of those particular theories. We are testing two theories.
Integrated information theory and global neuronal workspace theory. They differ fundamentally in their assumption, and they make some interesting distinction between where they locate the footprints of consciousness. Integrated information theory ultimately says consciousness is associated with the causal power of systems like the brain to determine their own future and to be influenced by the immediate past. Any system that has this causal power upon itself will be conscious, according to integrated information theory. Global neuronal workspace, that really argues that consciousness happens when information arises through my sensor. There's vision, there's audition, there's language, there's memory, etc. Those are all local processes. But once the information in my brain is made broadly accessible, so it broadcasts to all the different subsystems of the brain, in that act of broadcasting, it becomes conscious. Global neuronal workspace theory argues it's really the front part, the prefrontal cortex, that's heavily involved in consciousness. Front of the brain is critical for things like language, for planning, for intelligent action, for reasoning. Integrated information theory says no, it looks like really consciousness is sort of more restricted to what it's called a posterior hot zone. It's the back of the cerebral cortex that's really critically involved. And so this is one of the things that we are trying to test now. Are the footprints of consciousness, are they in the front of the brain or in the back of the brain?
The way in which we usually do science is that we take the views that we like, we run experiments to kind of like confirm the theory, and then we're happy.
And so typically what happens, somebody will only publish if they find evidence in favor of their theory.
But then there is another guy who actually thinks differently, and then he runs his experiments or her experiment, confirms his or her views, and they don't talk to each other. They have this data and then they silo those data. Nobody else looks at those data. So then you cannot test other hypotheses on those data. We decided to devise protocols by which we test the whole arsenal of techniques that we have in human neuroscience. So it would be fMRI, EMG and EEG, and also intracranial recordings.
And in all these cases, trying to track the footprint of when they're actually conscious of something and where does that footprint is and how strong is it and what's the temporal dynamics of that.
What is enabling and cannot be underestimated is the open science aspect that we are embarked on. Open science is making the protocols, experiments, data, and analysis shareable, open to the whole public. and everyone is allowed to download them, play with them. They can investigate even mysteries of the brain that do not necessarily pertain to consciousness, and that could trigger new discoveries. To my knowledge, there is nothing like this around, period.
The secret of the universe. I mean, what else?
What Templeton is mediating is giving us the key to do new things. And not just for consciousness and beyond.
And of course, my personal desire is to understand how consciousness fits into the general scheme of the universe and what it tells us about who else is conscious. I've always in my heart been very sympathetic to that consciousness is not only a property of sort of you and me and great apes, but that many animals, and perhaps most animals, like a bee, there's no reason a priori to rule out the fact that it doesn't feel like something, to just have drunk some golden nectar and to fly home in the warm sunlight. I believe consciousness is much more widespread than we believe in this grand universe that we find ourselves in.